Hello, welcome to my presentation. My name is Olduz. I'm a supervisor at DTU Compute, Technical University of Denmark. Currently, I'm contributing with DTU Health Tech. Our project is about a smartphone app for melanoma skin cancer detection. First of all, let's talk a little bit about skin cancer and different types of that, and why early detection of melanoma is key. Skin cancer is constantly extended on the skin by exposure to the sun, and it causes skin cancer to grow abnormally. It is also common for skin cancer to appear on the parts of the body that are not exposed to sunlight. The main three significant types of skin cancer are melanoma, squamous cell, and the basal cell carcinoma. In this project, the research is done based on melanomas. We choose melanoma because it's the deadliest type of skin cancer. The death rates are increasing every year. But what is melanoma? It is defined as a malignant proliferation of the pigment-forming cells of the skin, known as melanocytes. It can be painful with burn and itch. It can affect people with any type of skin color. The mole can change in size, color, feel, and can even bleed in some cases. Why early detection of melanoma is key? Because if the melanoma goes untreated, the survival rate is less than 5% within 2 years and is able to spread via metastasis. In this figure, I choose some images of melanomas. A and B are benign melanoma, and C and D are malignant melanomas. The lesions are usually small with regular or irregular borders. The most common color of skin lesion are red, pink, blue, blue-black, and white. Based on the ABCD algorithm, submalignant melanomas are characterized as asymmetrical, have irregular borders with edges and notched corners, and present some dark regions. Our contribution in this project is the development of the portable device for malignant melanoma detection and monitoring using a built-in camera of Samsung Galaxy A51 smartphone. The user of the app are patients and doctors. For the implementation, our team applied their knowledge on image processing, picture extraction, and classification using machine learning techniques. The implementation are done in three different steps. Applied advanced image processing analysis using OpenCV on Java, classification of benign and malignant melanomas, development of an app using Android Studio and Firebase as for user authentications. For collecting data, we use open source data, images around 3,000 images, and those are labeled. The main goal are to achieve an accurate segmentation of melanoma images, high classification accuracy, specificity, and sensitivity using supervector machine classification model, and the creation of the notebook using Firebase, both for real-time database and authentications. Last but not least, the aim is implement to a user-friendly device accessible for any type of users. In this project, we designed two different flowcharts, one for image processing part and the other one for the Android Studio procedure. Let's have a closer look at that in more detail. So for the image processing part, we collected labeled image, pre-processing, segmentation, feature extraction, classification, evaluation, and performance. For the collecting labeled images included both benign and malignant with hair and without hair from this source. For the pre-processing and segmentation, which is important to improve the quality of the image and even classification results, we choose some method like thresholding, using multi-threshold function using OTSO method, dilation using IM dilate, and IM fill in order to fill the small holes. Erosion, which is the opposite side of dilation, using IM erode function, mean filter, and then BW perim in order to get the segmentation boundary. So for the feature extraction, the feature selection is based on ABCD criteria, asymmetry, border irregularity, color variation, and diameter of the skin lesion. However, we also used other types of the features found to be relevant for the melanoma classification in the literature. And those are as follows: compactness, solidity, variance of distance, asymmetry, local binary patterns, mean and variance for RGB, HSV, and grayscale image, edge density function using Connie edge detection, GLCM features like contrast, homogeneity, correlation, and energy, eccentricity, fractional dimension, and wavelet decomposition using hard transform features. For the Android Studio procedure, the user can start with registration. And if he already registered, he press log in. And then he goes to 4 different activities: new examination, archived examination, settings, and medical information. For the new examination, there are also some other options like choose to take a photo, enter the melanoma reference, submit the photo, or go to archive, proceed as a doctor, or proceed as a patient. There are 2 options here, and display segmentation result and also classification result. Archived examination, which is the user's notebook, then he can save the examination results. In the settings, he can go to his profile, edit profile, get some helps, and even log out. And the medical information link for skin cancer information in order to educate the user about the skin cancer, and links for doctor's contact. Here I choose some image preprocessing and segmentation results. This figure here is more general, where we have our original image, do preprocessing on that, and then do segmentation, and result is segmented boundary. Here this figure shows in more detail, where we have our original image using a binary, using OTSO method to get the result of a binary thresholded image, and dilated binary image, field image, rotated image, mean filter, and then original image with the detected boundary. So the results of feature extraction in MATLAB, we have been displayed as box plot. 90 parameters have been used for the classification. From the box plot, we can see some of the features that have been used for the classification of the image into benign or malignant melanomas. Some features are good indicator to separate the image into 2 different classes, as we can see here in this figure. This figure is the result of compactness feature extraction for the benign and malignant, and the y-axis shows the value of the features for the benign here, and the value of the features here for the malignant one. But in overall, we observe that the combination of all features together can give us a higher classification accuracy. For the classification and evaluation of the performance in MATLAB, we use the per-vector machine model for the binary classification. It is the most popular classification model in healthcare. The effectiveness of SVM and higher performance of the model in analyzing different types of medical data and predicting diseases with a higher accuracy convinced us to choose this model in this project. And we choose the different forms of SVM like cubic SVM, linear SVM, medium Gaussian SVM, and quadratic SVM. And the highest validation accuracy is achieved with a quadratic SVM with an accuracy of 80.4%. And the other results you can see in confusion metrics, where we have our true class here and predicted class here. Those are true negative, true positive, false positive, and false negative. And those are the accuracy, sensitivity, and specificity of different form of SVM. And as I mentioned before, the highest validation accuracy was for quadratic SVM. Here I choose some results of a screenshot of our app. We call that it's small k, where the user can create with an account, like by full name, email, CPR number, and then press register. If he already registered, then press login. And then he goes to 4 different options, where new examination, notebook, settings, medical information. For the medical information, he can see to go to about skin cancer and doctor's contacts. And for the settings, he go to my profile, edit profile, help, and log out. Here are also some results of some actions where the user can take a photo, proceed as a patient, proceed as a doctor, and then see the segmentation results and then classification results. The difference between proceed as patient and proceed as doctor can see also list of features. Yes, that was our project. Thanks for your attention. I hope you enjoyed that. Bye.